Automatic Addison.
In this tutorial, I'll walk you through the entire process of installing Nav2, the ROS2 navigation software stack. By the end of this tutorial, you will have Nav2 fully installed on your system and you will be able to run this demo. ROS2 navigation, or Nav2 for short, is a set of ROS2 packages that provide a complete solution for autonomous robot navigation. It includes modules for localization, mapping, path planning, and control, allowing robots to navigate through their environment safely and efficiently. Nav2 is built on top of the ROS2 framework, leveraging its modularity, scalability, and robustness. Now let's talk about some real-world applications. Nav2 has numerous real-world applications across various industries. Some examples include warehouse automation, so you can think of like autonomous mobile robots equipped with Nav2 that can navigate warehouses, pick up and deliver goods, and optimize inventory management. And let's just lump healthcare and hospitality in one group. So robots powered by Nav2 can assist in hospitals, hotels, and restaurants navigating through dynamic environments and interacting with humans. Another real-world application is agricultural robots. Nav2 enables autonomous tractors and harvesters to navigate fields, monitor crops, and perform precision farming tasks. Nav2 is versatile and can be used with a wide range of robot platforms, including differential drive robots. So you've got robots with two independently driven wheels, such as the Turtlebot, or maybe you're familiar with the iRobot Create. Those are differential drive robots. Then we've got holonomic robots. So these are robots that can move in any direction without changing their orientation. This is like the Yaboom ROSmaster X3 that I'm using in my tutorials. And then finally, you've got the Ackerman steering robots. These are robots with car-like steering, such as autonomous vehicles and some agricultural robots. So your own car, that's Ackerman steering. All right, let's create a package. So first, navigate to your workspace, cd ROS2, source Yaboom ROSmaster. Okay, we are inside the Yaboom ROSmaster directory, and let's create a package. So ROS2 pkg create -- build type amint underscore CMake. And then we'll do license BSD3 clause -- maintainer name. Let's do maintainer name Ubuntu, and then do maintainer email. We'll do automatic addison@todo.com. And then the name of the package is going to be Yaboom ROSmaster Localization. Okay, and let's press enter. Oh, we made a mistake here. So let's do remove rf Yaboom ROSmaster Localization. Okay, let's type that command again, and let's go up here, BSD3, and then let's make that a hyphen. Enter again. Okay, now we're good. Let's create another package called navigation. Enter. Okay, now we need to update the package.xml files for all the packages. So let's do Yaboom ROSmaster Localization. Let's get it package.xml. Okay, we're in the Yaboom ROSmaster Localization. And right now we need to update our package.xml. So let's create a nice, good description here on line 6. I'm going to say localization package for ROSmaster series robots by Yaboom. Yaboom. And let's add a dependency in here. So build to dependent. Let's do open alligator. Let's do depend. Let's add a dependency here. We're going to add the robot localization package, which you're going to be using later. And save. Looking good. Okay, now let's go cd dot dot, cd dot dot right there. Let's go into the Yaboom ROS Master navigation package. Let's go get it, package.xml. Okay. And for our description here, let's go here. Let's go navigation package for ROS Master Series Robots by Yaboom. Save. Okay, and then CMake. Okay, and now let's add some dependencies in here, which we're going to use later. So build tool underscore depend, and let's do a mint CMake Python, and build tool underscore depend, and then save. Okay, now underneath the cement CMake Python, we're going to add all these dependencies here. So I copied and pasted. You can copy and paste from the package.xml of my Yaboom ROS Master navigation that you see on GitHub. Make sure you have these right here, these dependencies listed. Got the C++ library. We've got Python library, built-in interfaces, geometry messages, Nav2, bring up package, simple commander API, slam toolbox, stood messages, TF2 ROS, and TF transformations. Make sure that is in your package.xml of your Yaboom ROS Master navigation package. Now we need to update the meta package. So let's do cd dot dot. cd Yaboom ROS Master clear. Okay, I'm in the Yaboom ROS Master folder of the Yaboom ROS Master package, and let's do get it package.xml. Okay, and let's update that package.xml file with the new stuff. So what do we have new? We've got bring up, we've got description, we've got gazebo, got system test, and let's add the localization in alphabetical order. I like to do it in alphabetical order. Okay. Add these two puppies right here. Let's go over to here, 8, B, C, D, E, F, G, H, I, J, K, L, M. So we'll do L, M, N. So localization. And let's add navigation. Okay. Everything looking good there. All right, let's now move on to the CMakeLists.txt. Okay, now I want you to go to the Yaboom ROS Master navigation package. Let's open CMakeList.txt. Okay, and now we need to add some blocks in here. Add some blocks in here. So let's get rid of this comment right there under a mint CMake. And remember all those packages that we added to the package.xml. These puppies need to be copied and pasted onto line 10. So do that now. You see that here? Geometry messages, navigation 2, nav2 bring up, RCL CPP library, the Python library, slam toolbox, stood messages, and TF2 ROS. Add that in here. Save. Okay, and now we need to go over here to the robot localization package. cd Yaboom ROS Master localization. Okay, And again, I want you to remove this comment right here. Okay, and what do you think we need to add now on line 10? Remember the package XML? Remember what we added? We need to add here, we need to do find package, and we need robot localization package. This is a ROS2 package. So the reason why we add it here is because it's a dependency of some code we're going to write here in the net localization package. And we want to make sure that when we have this package, that whatever code that we're running with this package is able to access the robot localization package. And we want to also, the reason why we add it to the package XML is so that when somebody else takes your robot, your Yaboom ROS master localization package and puts it in their own workspace and runs the appropriate command, that the robot localization package will automatically install. So you don't need to do the sudo apt-get install. This will do this automatically, assuming that you've added that to your package XML. All right, we have added it to our CMakeLists.txt. And you know what comes next? Building our workspace. Okay, now it's time to build the workspace. So let's clear. Open up a new terminal. Terminal stuck. Okay, so let's do cd ROS2 workspace. Let's do ROS dep install -- from pass. What this command is doing is it's making sure that you install all the required dependencies that we set in our package XML files for Yaboom ROS master localization and Yaboom ROS master navigation. So from pass source ignore source -r and then -y. Okay, and you see the the ROS Jazzy robot localization package. We're automatically getting a prompt to install it. That's what we want. You type the password on your machine and we install and let it do its thing. It'll take some time to install. Okay, it's done. Okay, and remember, you can type this build command as well. I have this build alias, which I have set in here. Build, which CDs into your workspace, and then it runs a colcon build, and then it sources the bash. So anytime I want to build, I can always just run the build command. Alrighty. Okay, now I want you to test your installation, and to do that, type the following command: ROS2 launch Nav2 bring up TB3 simulation.launch.py, and let's do headless false. Headless, no. So we do not want headless mode. We want to see all the GUI in all of its glory. So we set headless to false. Press enter. Okay, everything is loaded over here. Let's zoom in. We can see the robot over here on the left side. And we need to set the pose, the position and orientation of the robot. So up here you have this 2D pose estimate button. We kind of see the robot is right here. So we've got 1, 2, 3 pylons, and the robot is a meter behind these 2 pylons on the right. So it's right around here is where we're going to set the pose. So click the 2D pose estimate button. Okay, and you're going to click right here and drag forward. So click and then hold the mouse button down and drag forward to set the orientation. And that sets the initial position and orientation of the robot. Okay, gazebo. Okay, see our logs dancing around here. Let's zoom in, press the middle mouse button and hold. And now let's set a navigation goal. So you click the Nav2 goal button right up here at the top of our viz. And you click anywhere you want to on here. You can also click, hold down, and drag to set a specific orientation as well as position. And let's do that here. So I want to move the robot right here. I'm going to click, hold down, and I want to be facing down, facing south. And release. And you can see our robot over here in Gazebo moving towards the goal. And then it's going to turn around when it reaches that goal. See it turning around. Okay. Goal succeeded. Now press Control-C to close everything. Everything's working with navigation. Now, how about we test mapping, the ability to create a map? Let's do that now. Create a map, or at least get the process started. So I'm going to clear, and let's do ROS2, launch, Nav2, bring up, and let's do TB4 underscore simulation. .launch.py slam equals true. And then headless equal false. Let's click wait, let it come up. Looks like it's having some issues and taking some time. Let's click wait. Let's be a little bit more patient. Wait again. Click wait again. Okay. Wait again. That's a very heavy gazebo simulation environment. You can see it's got a lot of stuff in it. Let's expand that out. It's like a warehouse with oil drums and brick walls and boxes and everything. So that's why it was taking so long to load forklifts. It's got lots of pallet jacks, actually. It's got lots of different stuff in here. Very cool, cool world. All right, very nice. Let's zoom out. You can see it. Okay, and where's our robot? There he is, right down here. This is our Turtlebot 4 down here. This guy down here, that's our robot. Zoom in so you can see it. Okay, and let's say we want to create a map of this warehouse. We can move it around using RViz. So let's get this in the center. So just to let you know, so when the robot first starts out, it starts out here. This white area are known areas, known clear areas. So it uses its LiDAR scanner, okay, to create a map of the environment. And the LiDAR sends out LiDAR scans, okay? And when these known areas get known, it appears as white on RViz. These are the unknown areas out here in this gray. And as the robot moves around, we're going to have less and less, fewer and fewer unknown areas as the robot explores the region. So let's start moving the robot. Click Nav2 goal. Let's just click to the edge of one of these known areas. And you're going to see the robot will move. So ever so slowly. Okay, it's better to watch RViz. You can see now we've got more known areas as we move the robot around to the edge of the known. Robot keeps moving. Just keep a look at RViz. Okay, now we're really starting to get more known areas. Let's move it around. Keep building our map. That's really all there is to it. You're just going to keep sending it towards goals. You can also teleoperate the robot manually by sending raw velocity commands, but you can see it's starting to create a nice little map of the environment as it moves around and explores using its LiDAR. Let's go to some more known areas. Let's go to the edge of here. Okay. And if for some reason when you set a goal and it doesn't move, you probably set a goal in an unknown area. So yeah, just send it to the edge. I call it these frontiers, these edge between the known areas and the unknown areas. Okay, starting to look good. Okay, and we won't finish this, but you can see it's creating a nice map of the environment. We just keep sending it goals. It would move around, and eventually you're going to have a complete map in RViz. So that's it. That is the process where you install ROS2 navigation and check to see if it's installed by running the demos that run right out of the box. Thank you for watching this tutorial, and keep building.